What's happening, folks? Geologist Philip Prince looking out over the landscape of Kerr County, Texas. This, of course, is before the flood that just occurred there, but I wanted to use some LiDAR imagery from the U.S. Geological Survey to talk a little bit more about where a flood like the one we just saw actually starts. And when you think of flooding, of course, you think of rivers. That's where the flooding occurs and does its damage, but it really starts on the landscape. And that's because there's a lot more land surface in a drainage basin than there is actual water surface area with rivers and streams because they're pretty narrow. Water has to fall on that land and actually get into those streams, and those streams have to come together to get bigger and bigger, turn into rivers, and actually produce the flooding. So it's really where the water hits the land as rainfall and makes its way downhill where the flooding actually begins. Talked about in a previous video, this idea of high drainage density, meaning there's a tremendous number of little channels in the landscape here in this part of Texas. LiDAR imagery, when we're zoomed in really close like this, does a really good job of showing you what that looks like. I'm going to trace them in blue here just to give you a sense of how these tiny little channels sit in the land and how they sort of branch and come together to make, in this case, just a very small little stream network. The overall size of what I'm drawing here in the landscape, it really is not very big. And to see this tremendous number of these small little branches all splitting off of what's already a small stream is something that you really legitimately, as we'll see later in this video, do not see in every single landscape. And these are stream channels that are actually they're cutting into the rock. We'll draw one right here. You can follow this rock layer around and you can see where the water has sort of carved a groove down through that rock there. So this legitimately is a very specific landscape style, and it's something that you see in this particular case because of the geology. I'm going to use brown here to highlight these really closely spaced rock layers. This is a limestone dominated landscape. I think there are some shale layers mixed in there as well. But both of those rock types, as they weather away, they leave a bit of clay behind. Collectively, they tend to not make a lot of soil. A lot of people talk about the thin soil here. The soil that's present is dominated by clay. That does not do the best job of soaking up water. It'll bake and kind of dry out and get hard in drought conditions. When rain finally does come, it'll wet just the outer part of that thin clayey soil and the water will sheet off really quickly. And when you have large amounts of water just kind of sheeting down the landscape, that leads to the development of these closely spaced channels. So it really does come back to the geology. If you did not have the type of rocks that you have here, producing the type of soil that you have here, combined with the climate, tends to be pretty dry, but interspersed with dry periods or these incredible rainfall events. All of these factors come together to create a landscape that's capable of producing events like the one we just saw, right? The area that you're looking at here is quite small. I think if you were to draw this length right here, it'd be about 1,000 feet or something like that, maybe a little bit less, maybe a little bit more. But to have a stream channel of that length cut into the rock and to have all of these little branches coming off of it over that size, yes, that is specific to this landscape. So when you put it all together, you got who knows how many of these little channels like this. They're everywhere, and that's what allows water to come off of this landscape so very quickly. In addition to the channels, given the soil conditions, given the steepness of the slopes are fairly steep, but they tend to be short. There's not a huge amount of elevation difference here. You can probably have water in producing what we call sheet flow or like an overland flow, just sort of sheeting down the surface, particularly with intense rainfall. And all of that, of course, is being collected by the South Fork of the Guadalupe River down there. And when you take this effect and combine it over a really big area, that's how you get a flood like the one that we saw. Um, what you see here, what I've illustrated, because of the nature of the geology, it's everywhere for many miles. That's sort of the uniformity, if you want to call it that, that you see here, is really a big part of the issue. So does everywhere look like this? I mean, let's take it back real quick to the aerial imagery there, so you can just see the surface of the land. There are some drier looking areas. It's actually possible in an image like this to see some of those layers of rock, probably some of the tougher limestone layers poking out there. There is again a little bit of soil in the landscape, not much. A drier landscape, certainly at the time that this image was taken, and probably know that that's not what every part of the U.S. or the world looks like. So let's compare this to a landscape that saw pretty significant flooding in fairly recent history. This is in Buncombe County, North Carolina, Appalachian Mountains, pretty close to Swannanoa. That's the LiDAR imagery, but let's just look at the land surface. Absolutely covered in trees. You put a lot of hard rainfall on it, you're going to see a different effect just in terms of rainfall reaching the landscape, right? Let's take a look at it with that LiDAR imagery there. What are you going to see here if we kind of tilt this to show the overall lay of the landscape? And again, it's something very different. You don't see those evenly spaced ribs of bedrock. You don't see a little channel carved into the bedrock everywhere. In fact, large portions of this landscape, let's see, we use a brighter color here. You know, like you don't really see any channel activity at all in a part of the landscape like that one. It's covered in soil. There are outcrops of rock here. See some there, see some there. But in addition to that, there are these huge accumulations of sediment, which would be like boulders and and kind of cobble-sized rocks that have come down off of the mountains in past landslide events. In fact, landsliding would be the main hazard in this landscape because there is so much soil on it on these big steep slopes. If you were to have a rainfall event like you saw in Kerr County fall on a place like this, the immediate concern is going to be debris flow style landsliding, we call like mudslides in the news. It's a totally different style of land surface. It's a totally different style of slope, and it acts very differently when you put a lot of water on it. Now, are there streams here? Oh yeah, there's plenty of them because it's a fairly wet landscape, but their sort of branching patterns are different than what you see there in the Texas Hill Country. It could be said that the landscape you see here does have a pretty high drainage density. There's a lot of streams on it, but it's absolutely measurably. You can look at it on a map and measure the differences between this and what you see there in Kerr County. So, what's actually driving this? Well, this is a geologically very distinct landscape from what you have in the Texas Hill Country. And if you zoom out here and look at the layout of these mountains, you don't see those sort of tree branching style drainage networks producing the overall topographic pattern that you have in the hill country. So what's underneath all of this? It really does come back to what kind of rocks are present in terms both of what sort of soil they make and also the type of landforms that they make that rivers cut into and interact with to sort of wear away the landscape over time. So draw out a pretty simple comparison here. So we'll have our hill country on this side, and then we're going to have our Appalachian mountain style landscape over here. And the reason that these places look so different is all going to come down to what's down under the ground surface. So down here in hill country land, I introduced this a little bit in the last video, but to kind of build it out with a little more detail, flat-lying sedimentary rock, sort of as far as the eye can see. increase the size of that just a little bit. Come over here to the Appalachians, and you're going to see some kind of these crazy folded bedrock patterns. Nothing's going to be flat lying here. The rocks are going to be made of different minerals than what you see out there in Texas. And let's see here. We can probably do a little bit of filling in some colors here. We're gonna close these lines up. Let's see if this works. Oh yeah, got it that time. So there's gonna be our hill country landscape, and I don't know, we'll come over here, see what we got going. Do all kinds of colors here. We'll get kind of a darker one mixed in there, something like that. Sky's the limit here. Something like that. So we have a lot of geologic variety. And over here in the hill country, everywhere is going to produce sort of the same type of pattern, just repeated time and time and time again, because there isn't really any distinction in the landscape to make one part of it work that much differently from another one. And this sort of overall consistency is one of the reasons that if you put certain rainfall conditions on a landscape like this, you can get a very extreme effect in action over a huge, huge, huge geographic area. And you can funnel all that water down into one place and make an absolutely outrageous, almost unbelievable flood like the one we just saw. It truly is an aspect of the underlying geology. Now let's see what we got going on over here in the Appalachians. Well, each one of these different sort of folded, colorful layers here, they're going to make slightly different landforms. And you're going to see big mountains here that are associated with some of the rock types, smaller mountains associated with some of the other rock types, and all of that kind of wrinkling and structure is just going to make a lot of difference in the landscape. So you're not going to see that uniformity over huge areas that you got in the hill country there, which we're going to look at in Google Maps here momentarily. So what does this do to the landscape and the rivers? Well, over here in the hill country, first of all, you have a tremendous number of these channels. Pretty much every part of the landscape has got a steep little stream channel in close proximity to it. You put the rain on that, it's going to collect it all really, really quickly. You got that soil character mixed in with it, and you're off to the races. And so much of the landscape looks like that, that basically everything that comes out of an intense thunderstorm is going to act in the same way. Over here in the Appalachians, going to have kind of a more complicated setup. Um, First and foremost, on some of these mountain slopes, you're going to have huge amounts of soil, and you might even have in areas like the one you're looking at up here, almost like kind of hanging valleys in the landscape that are going to be sort of kept separate from the rest of the landscape by some kind of a localized river gorge here, almost like a canyon with incredible waterfalls in it. But you won't see those upstream of that canyon, and you won't see those downstream either. So you end up with very different parts, if you want to call it that, of the landscape. The river networks are a little more complex, and in this particular case, I've got my river there. It's going to have to flow over some really hard rock that's going to keep the area upstream acting differently. It's going to have lower slope. All of these areas have soil all over them. There might be these big deposits of material that have come down off the mountain slopes sitting there. There's really no stored soil like that in the Kerr County landscape. So these are just really, really different places. And it all comes down to what we've got illustrated here down under the ground. And yes, literally the geologies are that much different between the two places. So when you ask yourself, what you saw happen in Kerr County, like is that is that possible? Why doesn't that happen in other places? The conditions to make it happen are not there. Arid places like that, or places that are arid and dry for part of the year, they do tend to have bigger flash floods. A lot of that comes down to how the soil acts and sort of bakes and dries. And landscapes that have been in climates like that, they still erode away. They sort of have to, geologically speaking. They're not able to do that all the time, so when the rain comes, they have to make the most of it. And that's why they tend to evolve into conditions that make these crazy floods. So when you think of that Guadalupe River landscape, it actually has almost as great a capacity as anywhere on planet Earth to produce water runoff. Like for a given surface area in that landscape, it can produce as much runoff for that area as just about anywhere on the planet because of the conditions that we've talked about here, right? You don't have that in the Appalachians. Can you have incredible floods in the Appalachians? Absolutely. But the nature of the response due to the landscape and what's under it making that landscape, it's going to be different, right? So when you look at these landscapes compared to one another, you got Kerr County up there at the top, and the Appalachians in North Carolina down there at the bottom. They're they're distinct. The images you're looking at here, it's two map shots of that LiDAR imagery. They're the same size, right? So they're at the same scale. And it's sort of interesting to do this because you actually get a sense of kind of how big, if you like, how big is a mountain like you see right there, how big is that in terms of that Kerr County landscape? And well, you could come up there and, draw kind of a similar size thing. So if you were in the Appalachians, you'd see all these mountains you wouldn't be able to see in the next valley. What you got up there in Kerr County is just a huge, huge area that is full of nothing but these little creek channels and these incredible branch network coming together. And it's like that for just miles and miles and miles and miles in any given direction. And that's why if you put an incredible thunderstorm in that landscape, it's going to produce a response, kind of like the one that you saw here. It can be interesting actually just to zoom in here a little bit and look at just how closely packed some of these little drainages are. Again, something that you can see from the large scale. You can look at this landscape zoomed way out and already have a sense that it's going to do this kind of thing. But when you get in closer and closer, you really begin to appreciate what makes it do what it does and how it is in every way so much different from a landscape like the one you're looking at here that did have tremendous effects from flooding during Helene last fall, most recently. But that requires a different weather setup. You have to sort of prime the landscape, get the thick soils saturated, and then once they are saturated, yes, they produce a lot of runoff, but something like the landslide hazard is going to be what you're going to be most worried about, where you would have something like a big landslide start up here and send this debris flow coming down a drainage like that. So understanding where you are is an important part of understanding what could happen in any given landscape. And as we just saw in Kerr County, that's a pretty particular type of landscape, and it is capable of a pretty particular type of behavior. And just what do you what do you see when you step, way back there? Looking out over miles and miles and miles right here, you can actually see the location of Camp Mystic right there. We'll draw in as a good portion here of the South Fork of the Guadalupe. Probably take the screen a minute to catch up there. Uh, just everything you see here has that has that shallow soil, flat-lying bedrock, tons of little channels. That is the condition over everything that you see. and the precipitation that actually fell during the storm, it the most intense rain, it almost sat something like that almost perfectly on top of this one river system, and it just funneled all that into the flooding river. Something interesting to consider that's been mentioned by a few folks is that if you look just down at the bottom edge of the screen there, it's got the headwaters of the Medina River. So this is a river system that has very similar characteristics, but it goes another way. It's not part of the Guadalupe River basin. So if the rain had fallen in a slightly different location, you still would have seen rapid runoff being funneled into these drainages, but it wouldn't have all gone into the Guadalupe. So there was an element of just where the rain fell with respect to how these river systems are laid out. Regardless of where it falls, if it falls with that intensity, something extreme is going to happen here. But as with any huge disaster like this one, there's always a variety of characteristics that come together to sort of push it to the next level and produce something that really no one alive today has seen. To my knowledge, what just happened in Kerr County is what we would call like the event of record. It's really not been seen before by anyone living. Certainly something like that or even bigger may have happened in the past, but in terms of recorded history, this is now the benchmark of intensity. So I hope this helped with a little bit more understanding, sort of an expansion on the last video, which was kind of a big picture thing. But it's important to remember that wherever you are on Earth, the land looks like it does for certain reasons, and frequently they're very much geologic. They have to do with what's underneath you, and that relates to the rock and the soil that forms from the breakdown of the rock. And it's very important to understand what those conditions are going to produce. If you took the landscape on the left-hand side, our Kerr County style, Guadalupe style landscape there, if you put a 100 feet of sandstone into that, it would totally change things. It would change the layout of the river systems. There would be more sand available in the soil. There would be big boulders piling up in the landscape, and you would have something that behaves entirely differently from what you're looking at here, which is absolutely a geologically controlled landscape, a very specific one, and one that's capable of certain things. So keeping geology in mind is important, and geologists spend a huge amount of time actually studying these finer points of the land, like what happens when you have all these little channels in a shallow soil rocky landscape. Like what is that going to do to flood behavior, right? So hope you found this interesting. Hope you check out the next video when it comes along.